Welcome to Lesson 9 of my Visual C# language series. In this video we are going to be covering classes and object-oriented programming. Okay, so let's get started. I've already created an application called Lesson 09. It's very similar. We've been doing the calculator application as an example for a lot of our videos. And this time I've added two functionalities. This time it adds and it also multiplies. And if we go into our code here, whenever we click one of these buttons, it calls the calculate values function and sends in a string value of either add or multiply. And then we go into the calculate values function, which has a parameter of calculation, which is a string. We put this all in the try catch block, where we declare two doubles and we set them equal to the text box 1 and the text box 2. We have an if statement, which tests if the calculation parameter equals to add or equals to multiply. And if it does, if it equals to add, then we add first number and second number and show it in a message box. If it equals to multiply, then we create a double called product. We multiply first number and second number, and we show it in a message box. And if any errors, we have a default exception handler called exception exe, and we just have it show the message. So let's go ahead and compile this. And 4, 5, add 9, multiply 20. Okay. So by the end of this video, we're going to have this fully object-oriented. Okay. So in this video, we're going to be discussing about object-oriented programming and classes. And we're going to create our own class and make this whole application object based. So what exactly is object-oriented programming? Well, object-oriented programming is the concept or an idea that an application is just a ton of objects interacting with each other. That's the basic way of saying it, and how everything all doing with code has to do with classes and objects. So here's how I'm going to make it a little bit more easy to understand. The .NET framework, all it is a collection of objects. And you see here, the text box is an object, the button is an object, the checkbox is an object, the combo box is an object, the label is an object. Everything here is an object. And here are what are called namespaces. I didn't discuss using statement yet, and they basically import namespaces which contain classes, and I'll explain that a little later, and we can correlate these to objects. So everything in the whole language, all it is objects. So now I'm going to discuss classes. Now, when you have the .NET framework and you have it stored up, and you have your class right here declared. It doesn't say public partial object form 1. It says public partial class. And a class has a special distinction from an object. And this is how I learned it. A class is like a blueprint. It's basically instructions on how an object is made. For example here, this is how I learned it. A class can be like a set of instructions to make a batch of cookies. When you make a batch of cookies, follow the instructions. The cookies aren't the same. They aren't the exact same. Some might be a slightly browner, others might have a little more chocolate chips, but they all are cookies, and obviously made from the same recipe. And here's a perfect example of that, add and multiply. These both are buttons right here. As you see, now they are different shapes. Regardless of the fact that they are different shapes and have different text values, they are still buttons nonetheless. And this form right here, this is a class, and it's probably a lot different than a ton of other forms if we created other forms for this application, but there is no doubt hiding that they're all forms. So to recap this, a class is like a blueprint or a set of instructions to create an object. And an object is the real thing when the application compiles. Whoops. Whoa, how did I do that? Okay. See, I'm sorry about that. I clicked this right here, which gives you the option to do that. Whoops. Okay, I'm sorry about that. This is an object, this is an object, this is all an object. Okay, there we go. And the .NET framework is a set of classes. All code, I believe classes are stored in DLL files. You may have to correct me on this. And they just contain instructions for everything. And that's why the .NET framework is so important. And here we see the declaration of our class, which is called a form. Here's all our code. So everything is just interactions of objects. Okay, now we're going to create our own class. But first we're going to study this class right here, the form, and how this works. Okay, so we have public partial class form1. We're not going to worry about the partial, and we're not going to worry about this stuff right here. That has to do with slightly more advanced concepts, which I may talk about in a more advanced series of videos. But in here, as you see, we have a list of functions. And these are functions of the class. Right here. And as you see in here, when we call these functions, we just say the name of the function. We do not have to type in form1 dot, dot calculate values. But that is not necessary. Actually, that's not even correct. This calculate values. We don't have to do that because we are inside our own class and because of scope, which I didn't cover that much, but I may cover in another series of videos. Okay, well, that's one part of it. It's the declaration of all of our functions in the class. And also all the declarations of the variables. But there's one other critical important part, which is called the constructor. The constructor, if I can, how I say this, is basically the process of, say, when the set of instructions is turned into cookies. Process of how things are created and variables and values are instantiated. So this is kind of hard to explain, but if we go into the designer right here, actually, nope. I am sorry, guys. Nope. Okay, let me find it really quick. Yep, and Visual Studio hides the constructor, so it's kind of hard to find. Nope. Double click. There we go. Here's the constructor. Okay, so we have partial class form1. We have a protected override void function called dispose. It just deinstantiates a bool apparently. And we have private void initialize component, which was the function found here. This is all hidden to you, you can't see this. And then here is our constructor. As you see, we are setting all the values that a form can have in here to their respective values right here. We are making our buttons show up. We have our name of these miniature little objects right here. And it's all set up here. So this may be really difficult to explain, but let's go ahead and get started. We're going to select add new item. We're going to select our class, and we are going to name the class calculator. And we're going to click add. Okay, now that we have done that, we are going to proceed to put all of the stuff inside the class. So we're going to start by creating our calculator. So we're going to start by creating what looks like a function, but it really isn't. We have a public statement, and then we have the name of our class with 2 opening and closing parentheses. So this is what appears to be a function, but it's really called a constructor. And we'll get into that later once we have some values to put it in. now that we're going to type in public first number and public, oops, actually, I'm sorry about that, public double first number and public double second number. Okay, now once we have that, we are going to type in the constructor first number equals 0, the second number equals 0. Okay, so this is what we've done. We create a class called calculator, and we have given the class properties. So the object calculator has two properties. It has first number and it has second number. And when the class turns into an object, when the application runs, we set the value of first number to 0, and we set the value of second number to 0. Okay, so we have a class, and it has properties. Okay, let's add functions to it. Okay, and now that I mentioned that we have to add functions and some other values, I have to cover a concept called encapsulation, and I will cover that in a moment as soon as I add this in here. So we are going to create a function here. I like to separate my properties and my functions for the sake of organization. We're going to type in public, and we're going to type in void and add values. We're going to type in public void multiply values. Okay, here we go. And we're going to add in one more function, which is private void calculate values. Okay, now I can cover encapsulation. Encapsulation is a theory within object-oriented programming, which means that when you have a class, and when someone uses a class, you don't have to know how the class works. The class should be obvious in how it works, and you should be able to use the class without knowing anything about it. I just resaid what I just said, but here's a good example. When we type in messagebox.show, we have no idea how .NET accesses the Win32 API calls and how they display a message box and how they populate it with values and all that stuff. We have no idea how that works. We just know that it does it somehow. Let's see if I can get another value here as a good example. When we type in, let's say this dot close, we have no idea how .NET accesses the API and allows the form to close with all the message loop, and our C++ programmers know what I mean here. But we have no idea how it works. We just know that it works, and that's all we care about.